Jeff, can you do one more problem like that, similar to that?
Oh yeah, I'm gonna do several like that. I just want to see if anybody else had specific questions. All right. So let's do several examples like what I just did. Let's see. Should I do it up on the board? Ah, here we go. Here we go. Sweet. All kinds of blank space. All right. So what if I had this equation? What do you got, Jeff? A equals 5.2 plus 7x. And I have to solve this for x. So that's my instructions. It's currently solved for a. So all it means when it says solve for some letter, it means get that letter by itself. Can I add these two together? Can I add these two together? Can I add these two together?
No.
Hell no. Why not?
They're not like terms.
I like terms. Good. So don't do that shit, right? So I'm trying to get x by itself. Which term has x in it?
Seven.
So sorry?
Seven has the X.
Seven.
Yeah, this term, 7x, has x in it. I know that's kind of a silly question. Which term has x in it? The one's got freaking x in it, Jeff. But I really want to make sure you understand. Here's a term right here. This is a term, A. This is a term, 5.2. And this is a term, 7x. Terms are always separated by pluses and minuses on each side. Are you guys with me? I want you to know what I mean when I say term. So which term has the x in it? This one does. So I need to get that piece by itself on that side. Why is it not by itself? It's antisocial. What needs to get out of there?
The 5.2.
Yeah, on this side, he's not by himself because of this dumb guy. He's like, man, just leave me alone, man. I need some alone time. All right, so we're going to help. Let me rewrite it because we got all kinds of shit happening there. So I want to get this term by itself. So I'm going to get rid of the 5.2. So how do I get rid of this 5.2? What do I do to both sides?
Subtract it.
Yeah, why? Subtract who? Subtract it. Okay. Subtract 5.2 because that's the only operation I can do and it would cancel. All right, let me stop for a minute. Is everybody semi with me at the moment? Or, even to be more optimistic is say everybody completely with me. That would be great. Okay. What is a minus 5.2?
A minus
5.2.
Kick ass. A minus 5.2. I know some of you guys are like, what? I don't know what it is. That's exactly. I don't know what the shit it is. So I just write it down. A minus 5.2, whatever the hell that is, equals, and of course, the only thing left on this side is the 7x. And now I can get my x by itself. So it's almost always, find where x is and get that piece by itself. So then you can divide by the stupid number in front of it, and then x will be by itself. That's all x wants, is some alone time. It's like, get all this shit off of me, please. So what's the last thing I do here to get x by itself?
divided by 7.
Yeah, I want to get rid of this stupid 7. And it's currently multiplying the x. I'm going to divide by 7. I got too many lines going on here. Hold on. So divide by 7. So I get x equals a minus 5.2 divided by 7. No need to divide that thing out somehow. Just that's the answer. Now, what's interesting to me is if I give you this problem here, let me see what you got, Jeff. Sure. Most of the time, people can kind of figure out how to solve this quicker than they can figure out how to solve this. How do I solve this one? Or maybe I'm wrong. Maybe.
5.2 plus 7 first.
So again, we have got to not forget the basic stuff like order operations and like you can't combine them if they're not like terms, right? These are not like terms. I cannot put those together. We can't forget that. That is, when is that true? All the damn time, every time. Which class? Every class. What days? Every day. Every day that ends in Y, right? Are you guys understanding what I'm saying? So order operations, like terms, they don't live in a section of a book. They live in the entire universe everywhere for all time. You cannot combine them unless they're like terms. Oh, here we go. Yeah, okay. Somebody out there is like, God, just shut this guy up. Just tell him what to do. Okay. So somebody told me the right thing to do here. Again, find where my X is and get rid of the other thing. No, Jeff, that's gone. Boop, boop. And then what's the last step here?
Divided by 7.
Yeah, divide it by 7. Good. You almost always divide last. And look how I can just flip it around. Who cares? If 2 equals X, then X equals 2. I can just flip it around so it looks more like what I'm used to. Not a big deal. Now, just to complete the circle of life here, I want you to realize, how did I make this equation from this equation? What did I make A equal to make this equation over here? Can you guys see? What did I put in place of A?
19.2.
19.2. Kick ass. So if I put 19.2 into this guy, I already know I better get a frickin' 2 out because this is the same formula, just with A is 19.2. So if I put a 19.2 in for A, what do I get? Well, what's 19.2 minus 5.2? 14. What's 14 divided by 7? 2. All right, sweet. So when we solve an equation for a different variable, I called it like a new equation, but it really isn't. It's the same equation, just solved for a different variable, just solved for a different piece. So it doesn't matter if I plug 19.2 in here for A, or if I plug 19.2 in here for A, I'm going to get the same answer. Because it really is the same equation, just rewritten. All right, let's do some more examples. I'm going to take this away. You guys ready? Almost drown myself in tea. All right, so let me clear all this away. Bang. So what about, let's see. Where'd it go? There it is. So let's see, what if I have, what do you got, Jeff? I don't know. There's 26 letters. You could pick one. There you go, buddy. What if I have M equals 4.7 B minus C? Ooh, I like it even better. And I want you to solve this for B. Currently, what does it solve for? What is that equation currently solved for?
M.
Yep. Because if I know B and C, I plug them in and it's already solved for M. That's what that expression means. It's already solved for M. I need it solved for B instead. All right, let me take away my. Oh shit, I took away my B. Hold on. It's still there. My little eraser got a little excited. So what's the first thing I need to do? Where is my B? It's in this term. Why is that term not by itself on that side? Why is this not by itself? Does that make sense when I say that? Is anyone confused when I say by itself? Am I here? Do I exist? What's happening out there? Are you guys doing the problem? Talk to me. So why is this not by itself?
Because it has the negative C or
Because this
minus
C.
C.
Right. Yeah, it's that simple, right? I really want you guys all to understand the phrases I use. They're not like standard phrases, to be honest. They're the way I kind of look at math. But it makes sense. Hopefully it makes sense to some of you guys. This guy is not by itself because it's currently having C subtract from it. So how do I get this by itself then? I want to get rid of that minus C. So what do I do to both sides?
Add the C to the other side.
Add the C. Yeah, and can you see the C canceling?
Mm-hmm.
Yes, minus C plus C cancels. So now on this side, I've got my B term by himself. And on this side, what do I get?
M plus C.
Yeah, because I don't know what the hell M plus C is, so I just write it down. And then the last thing I need to do is get B by itself.
Mhm.
He's not by himself because it's stupid 4.7.
Divide it.
Yes, it's currently multiplying, so I'm going to divide. So I cancel the operation. So I do that to both sides. So I get B equals M plus C over 4.7. All right, so you guys try this one. Which one, Jeff? Give me a minute, hold on. All right, let's see. Let's see, L equals, sure. What do you got, Jeff? 2.1 W plus A. Sure, okay. Solve that for W. I'll just sit here. All right, guys. So what was the first thing you did?
By A.
Yes. Subtract A, because that's where your W is. You want to get rid of this dumb thing. So it cancels. And on this side, I get
W is equal to L
well, no.
minus
Don't, hey, stop. Don't jump ahead. What do I get on this side right now?
A. Okay.
L minus A.
L minus A. And on this side, I just have 2.1 W left, right?
Mm-hmm. Do 2.1 by 2.1.
Yeah, so now I want to get rid of this 2.1. It's multiplying, so I'm going to divide by it.
2.1. W is
W.
equal to L
What?
minus A 0.21.
2.1, okay. How's everybody doing? You guys, anybody not doing well? You guys all right out there? What's happening? Is this making any sense?
It's clear now. Thank
It
you.
is, but I kind of, I forgot, I forgot to put the minus. I put plus.
Oh, I see. All right.
You know what I mean? So,
Yeah. So that's why this is really important. The minute you identify what to do here, minus A, you immediately put the same exact thing on the other side.
right. But then you opposite of that plus too, though, of the positive, negative.
Yeah. Right now it's adding, so I must subtract. Yeah.
Right, to cancel it. And so,
Exactly.
yeah, yeah.
So
I
here's an
kinda got
example. Here's an example of a mistake somebody makes. I'm going to erase this blue business. I'm going to keep the green business. We're going to do something else with the green problem here in a minute. But let me show you a really quick example of a mistake related to what Linnell's talking about. This depends on how long it takes me to erase all this. Okay. Yeah, so if I had like 8 minus x equals 2, this is deceptively difficult. What I very, very often get is this kind of thing. That is wrong. Okay, please don't even write that down. Don't even. That is wrong. Check what you did up here, right? What's 8 plus 8?
16.
Freaking 16. And then there's a minus still there, right? So that's not the right thing to do at all. So when I do something, if I think it cancels, just make sure it does. So of course, what am I going to do instead of adding 8? I'm going to, how do I kill this 8?
Subtract 8.
Subtract 8, yes. And then I can see 8 minus 8 does cancel. And then what's left on this side? Negative x. And what's 2 minus 8?
6.
Careful. 8 minus 2 is 6. What's 2 minus 8?
Negative.
Yeah, negative 6, right? I got $2 and I owe you 8. I'm going to still owe you 6 if I pay you as much as I can, right? Now, am I done with this equation? Do I have x by itself?
No.
No, I don't. That kind of sucks. So what do I have to do to get x by itself? What's kind of in front of the x? What's understood to be in front of the x?
A 1.
A negative 1. So how do I get rid of that negative 1?
Divide.
Good, because it's negative 1 times x right now. So I get x equals, and the negatives cancel, 6. So when you're solving an equation and you think you just did something to cancel something out, just make sure it did. Like up here, 8 plus 8 is 16. They don't cancel each other out. So just take like a couple seconds for each thing you do and make sure it does what you think it does, right? Okay. All right, so I want to do one last thing with this problem with the L's and the A's. I'm going to erase all this. This stuff here is going to start to go away. There you go. If I'm just more calm about it.
Thought you was gonna say all this business, Jeff, but it's stuff this time.
Oh, okay. You never know what's going to come out of my mouth. Let me see.
Yeah, you usually erase all this business. Okay.
Sorry. All right.
We're gonna roll with stuff.
If I have this equation and I have, now watch, let me see if you guys are really with me on this, right? So what if I have a bunch of values for L and A? So for example, if I tell you that L is 5 and A is 3, could you figure out what W is? Of course
Yes.
you could. So go ahead and do it. So you know L is 5 and A is 3. So how would I rewrite this?
W equals 5 minus 3.
Now see now, Lakeisha, you're being too smart for me right now. So right now, I just want to use this guy.
Oh, I was on the other side. Sorry.
You're fine. That's the smart way to do it. That's the smart way to do it. But I'm trying to make a little point about this. So if I put
5 equals 2.1 W plus 3.
all right. And then just to cut to the chase, you would subtract 3, 2 equals 2.1 W. Then I would divide by 2.1. So I get W equals whatever the hell that is. I sure don't know. I don't know.
952.
0.952, blah, blah, blah,
Mhm.
blah, blah, blah. Now imagine this. Now here's the point I'm trying to make. What if I had like a bunch of values of L and A and I had to figure out all of them? Do you understand what's happening? So now I got L is 4 and A is 1. L is 7 and A is 5. L is 2 and A is 7. L is 11 and A is 3. And then I got to figure out all the W's. Now, Nikisha already figured this out, which kicks ass. I would much rather use this equation because otherwise, every time I go to a different row, I'd have to solve for W again. Why not have an equation that is already solved for W? That is the most basic reason. And trust me, that is not the only reason. It's the most basic reason why it's good to know how to solve equations for other pieces, other variables, because they could be more useful form. Does that make any sense? I want you to really understand why we're focusing on a skill. Because as a student, I know in your head, you're like, why the hell is this useful, right? Now, it's not going to help you buy milk. I love it. One semester, some kid was like, how's this going to help me buy milk? I'm like, all right, dude, I don't even know. Is that the most important thing in your life right now is buying milk? Then I'm sorry. I can't. So this is a good skill within mathematics, which is where we are at the moment. All right. Everybody okay out there? You guys all right? All right. All right. All right, guys. Anything else from homework stuff before I jump back into where I left off?
Yes. How do we find the area when we have the width and the length times A equals L times? Okay.
You got it. You got it.
Okay.
Yeah, that's a neat problem. The one about the perimeter and the area, right? All right. All right, let me clear all this. I'm going to clear all this away. Bam. And what I want to do, if there's no other questions, because remember what's happening today after class.
Quiz.
Quiz, yes. So it's 3-1-3-2-3-3 is what the quiz is covering. So right now is the time to let me know if you have any other questions from those before I get back into where we left off. All right. Let me see if I can jump to where we left off. Okay. So 3-4 was about inequalities, which is almost the same as solving equations. It's just if you divide or multiply and by a negative, you got to switch the sign. Does that ring a bell? So that's what 3-4 is. And last time we got into word problems, and I had that handout. Let me pull that handout back up just in case you weren't here. O'Reilly. There it is. All right, there it is. Scheisse, come over here. Share screen. Bam. So I have some examples, right? There's one with a triangle. We did a few with a triangle. There's one with men and women at a concert. And then we did, this is what we did. Look at that. Wow. Look at all we did. Dude, we did a lot of stuff. So let's do this. Before we get into brand new stuff, I don't know if anybody tried these, but try number 1 here, the one about Bob and Fred. Good old Bob and Fred. So don't forget, the first step is, in English, what are the players in the problem? Do this. Let's see. I'm going to put up here a clean so I have some room. So number 1 here.
Would it be how much Bob makes and then how much Fred makes and how much they make together?
Yeah, so how much, so the players, so I'm not doing number 4 here. I'm going to do number 1 up here. So number 1, the players in this is Bob's and Fred's what?
Income.
Income.
All right, so that's the first step. The first step in a word problem has nothing to do with math. It's just English. What are the parts? Now you also said together, but that's where what's going to come from?
1950.
Yeah, that's where the equation is going to come from. So the players are the parts, Bob's and Fred's income. The together is what those parts do together. So the parts are the players, the parts of the problem. So what are the parts of this problem? There's 2 parts, Bob's and Fred's money, their income for a week. Which one of these, Bob or Fred, which one is going to be just a letter? Which one does the other one depend on? I don't know if you guys can see that.
Fred.
Say it, sorry?
Fred.
Yes, can everybody see that? Bob makes 300 less than twice Fred. So I gotta freaking know Fred first. There's a lot of F's in that. Gotta freaking know Fred first.
I have a question.
Yes.
I'm getting super confused when it says, because this was yesterday, it was the same issue with me. It says 300 less than twice the money. Is twice the money the 1950 or is it? I'm just confused.
No,
What that
come on.
means. Okay.
Come on. All right, now watch.
Okay.
I could, now this is a really interesting point you're making that I want to focus on in a minute. But the first part of this equation has nothing to do with this because it just happens, I'm talking about last week. The week before that, would it have been 1950 necessarily?
No.
No, but for some reason, the way they've got their business set up, Bob always makes 300 less than twice Fred. So it depends on what week I'm talking about. So this part of the problem has nothing to do with what I'm about to set up here.
Okay, so 300 less than twice Fred. Like I just,
No,
it just,
stop.
I don't get it. Okay.
Sorry. So right there, does it make sense? Then I've got to know
Yeah.
Fred's income first. So
Yes.
does that make sense to everybody? Because one of the most important, if not the most important step, is which thing is just X or just a letter. So I think most of us, it sounds like nobody's speaking up that they don't understand why, but Fred needs a name first because Bob's math name is going to be built off of what Fred's is. Does that make sense? Bob's math name is 300 less than twice Fred. So I've got to know Fred first. So what do you guys want to call Fred's income? Give me a letter. What makes sense for Fred's income?
F.
Holy shit. I like it. I wanted somebody just to go, all right. Is that all right? So if Fred's income is F, why is it F? Because I don't know what it is. So what do we do in algebra when we don't know the value of something? We give it a variable. And a variable is just a placeholder. Instead of an empty space, I fill it with something, right? So now I can write Bob's income. If Fred's income is F, what's Bob's income? 300 less than twice that. So what's twice this?
2F minus
2F. And then,
300.
yeah. Minus 300. I love it. Remember that. Sorry, go ahead. Everybody all right? All right. Remember that less than phrase is an evil English. Why is that not working at all? Oh, because I'm not doing it that way, Jeff. I'm trying to erase shit the wrong way. That less than phrase is evil. It's English doing some weird shit to us like it always does. 300 less than twice is twice minus 300. It's backwards. And we discussed why that is. Is everybody decent with those two things here? Almost always in a word problem, there will be one player who gets a single letter and then all the other players build off of that letter. So that's why one of the most important steps is who gets just a letter, because he's what gets everything going. Everybody else is like, I don't know what to put until I know this dude. Now, all right, I really want you to get this next point. This models their incomes no matter what week it is. So the one I'm going to do is they make 1950 together. Another week they can make 3,000. Another week they can make 700. You guys understand what's happening? So how much money do they make together no matter what week it is? How do I write that? How much money, based on right here, how much money do they make together? What do I do with these two? Man, I got too much stuff here. Get some of this out of here.
You would add them.
Yes. So no matter what week it is, I would take Bob's income plus Fred's income to see how much they made together. Now, last week, it just happened to be true that they made $1,950 together. Therefore, this would equal $1,950, right?
Could you combine the F's to 3F minus 300?
Of course. Yes, and you could have done it before. I'm going to do it. But I tend, when we're first learning something, I tend to show a lot more steps than you need. But you're right. Right here, I could have made this 3F minus 300 beautiful, because that's what I'm going to do now, right? So that's fine. You're fine. So now I want to make sure, any questions on how I got that equation put together? This represents the amount of money they make together any week. And if I set it equal to the amount of money they made last week, I can figure out how much each one of them made. So I'm going to focus on the point I'm trying to make there in a minute. But let's finish this up. Now this should be the easy step. So like Riley already said, how do you start to solve this thing?
Combine like terms.
Yeah, so I got 2F and F is 3F minus 300. All right, then here's my F term, right? So here's my F. So how do we get that piece by itself?
Add 300 to the other side.
300. I like it. I'm not good at color coding stuff, but oh well. So we add Jeff. That's why I'm not good at that. Plus 300. Plus, oh, that's fluorescent green. I like it. Jeff. Trying to be all nifty. So 3F equals 2250. Just to take a major step back in time, what's 2 plus 2 plus 5 plus 0?
9.
So I know it's going to be divisible by 3, right? I know my answer is going to be a whole number. Because that's the next step, is divide by 3. So what do I get for F? 7.
750.
I like it. So what's that mean?
Fred makes $750.
Fred makes $750. And then how about Bob?
$450.
750, 450. No, not 450. So he's going to make
Make
twice.
1,200.
Yeah. So Bob makes twice Fred minus 300. That's 1,500 minus 300 is $1,200. Is that all right? I mean, once I know F, Bob builds on that. Do you guys see that? Once I know F, Bob is twice that minus 300. So then I can figure out what he is. Now, how do I know that's the right answer?
Plug 'em in.
To F.
Yeah, when you get 1,200, what's 1,200 plus 750?
$1950.
Which is what it's supposed to be, right? 1950. So I feel pretty good about what I just did. It actually does what it's supposed to do. I can always check the answer to a word problem by making sure that the players I got do what they're supposed to do. So these two incomes are supposed to make 1950 together. So then I can just add them together and I can see, oh, they make 1950. Yay. Okay, all right. So let me do something else with you guys. I'm gonna clear all, well, no, I don't have to clear it. That's right, because I'm doing this. Yay. I'm gonna go on the board. I'm getting tired of working on this dumb thing. So I'm gonna stop sharing my screen. You guys ready for that? Here we go. Bye, Bob and Fred. Okay, now. What I want to do a few things. I want you guys to see how I create problems, and that will help you figure out how to solve them. It'll make it make more sense. That's my hope. Anyway, so for example, let's do a rectangle problem. Somebody tell me a width. Somebody tell me what this is. Give me a number.
5.
5. Crazy. So that's 5 also. Now somebody give me this, a number bigger than 5.
8.
8. That's crazy. Okay, and that's 8 also. All right, you guys with me? Now, what's the perimeter of that thing we just created?
26.
26. Kick ass. And let's give these let's make these inches. So we got some beautiful units going on. All right. Now watch this. All right. My width is 5 and my length is 8. So can somebody give me one relationship between the length and the width? What's the relationship between the length and the width? How do they relate to each other?
They're both inches.
Inches.
I love you guys. So what I mean is one some amount more than the other? Is one twice the other one? That's what I mean.
8 is 3 less than Or
So the
8 is 3
length,
more.
so the length is 3 more than the width. Does everybody agree? It's kind of like, well, yeah, it is, Jeff. I can see it. Well, that's the point. So if I say the length is 3 more than the width. All right, that makes sense, Jeff. That's true. Now. So now I've made a problem. So I'm not going to use these. These are the answers, right? These are the answers. I'm going to give you this information. I have a rectangle where the length is 3 more than the width. And the perimeter is 26. So you're not going to see any of this shit. You're going to see that. We already know the answer, don't we? Because I let you in on my world. I know the answers because I start with them. Sometimes. I sometimes make a problem like this. Right? So let's see if we get the same answer. Now watch. So the length is 3 more than the width. So forget that we know the answers for a minute. Right? So I got length and I got width. Stay with me now. Stay with me now. So obviously, what's going to be just a letter? The length is 3 more than the width. So which one is just going to be a letter? Which one do I have to
W.
know? Yeah, the width I've got to know first. So let's call the width W. And then what's the length?
L.
No, it doesn't have to be its own letter because the length is 3 more than the width. So if the width is W, what's the length? It's 3 more than that.
3 plus W.
It is, yeah.
I like it. All right, let me stop for a minute. Now, of course, we're only going to show other people this. So you guys are all teachers now. You're making a problem right now. Your students are only going to see this. We know all this, ha, 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 but they're going to see this shit. But does it make sense so far? The width is 5 and the length is 5 plus 3. Right? I don't know if you guys are with me at all. So then what would the formula be for the perimeter? Right, it would be W plus 3 plus W plus W plus 3. I got to go all the way around, and that would equal 26. And then I could solve it. Are you guys with me? Now, we already know the answers, don't we? Because we're special. Is everybody okay with what I've done here? Anybody not okay with what we've done here? Is it freaking you out that I did this and then I did that? I don't know. That we created this problem. We know this problem will work because we already know what the answers are going to be. So let me see. So to do this real quick, W is 4W. 3 and 3 is 6. Right? Subtract 6 is 20. Divide by 4 is 5. So that's 5 inches. And 5 plus 3 is 8 inches, which is what we already knew the answer was going to be. Now, no. Stay with me. Let me go back. Now watch. Now stay with me. This is neat. So that would be a problem I could give you guys. You guys would get this problem. You'd figure it out. But I want to show you how I might create that problem. And I know ahead of time the answers are going to come out nice. You're not going to get something freaky because I start with nice numbers. Now stay with me. What if I start over? But I still want to use this. I still want the length to be 3 more than the width. So what if I make the width 10 and I still want the same relationship? What would the length be? I still want the length to be 3 more than the width. So if the width
10
is
plus
10,
3.
yes, the length will be 13. But now what's the perimeter of this thing now?
46.
Yes, 26, 36, 46. So the only, I really wish, I really hope. So this is still true, right? This is still true. I made sure this was still true because it's still 3 more than the width. I just started with a different number for the width. So now this is going to have to be 46. But see how this stays the same? Right? There's still, the width is W and the length is 3 more than the width. So this did not give a shit about what the perimeter actually is, because this is just how the length and the width relate to each other. So how many, so then to solve the equation, I would make that 46 and I would make that 46, blah, blah, blah. And then you would get W is 10. All right, so then you get the same answer. But that's not so important. I don't care about that. How many rectangles is this when I draw this shape? How many rectangles do I actually have here? That's a really strange question. But let me see if you guys get it. Did I change this picture? No, I just put a 10 there instead of 5. That's 2 rectangles right there. How many rectangles could have a length 3 more than the width? I know that might be a very strange question. An infinite number, right? If I make this 7, what's the length going to be? If it's 3 more than the width?
10.
10. Oh, I don't want 7. What if I make it 15? What's this going to be?
18.
18. Oh, I don't want 15. What if I make it 28? What's this going to be? 3 more.
31.
31. I don't, all right. I mean, so I can make an infinite number of problems where these are the same. Because all this says is the length is 3 more than the width. I can make the width anything I want to, and the length is going to be 3 more than that. It's a whole new rectangle. So that's kind of like the question about the perimeter does not affect what these are. They don't care because they have a relationship to each other. All right, let me try. So, So when we do, let me do this then. All right, I'm going to take all this away. We've already started doing it. So what if I said, Bob has 5 more than 3 times as many apples as Fred. Good old Bob and Fred, right? They make their money and they go buy apples. It's their life. They can do what they want. Bob has 5 more than 3 times as many apples as Fred. Can you guys, that's not enough information to solve anything. I don't care. Can you write the 2 players and what they would look like algebraically, right? So Bob's apples, the number of Bob's apples, and the number of Fred's apples. And you write the expressions. Which one would just be a letter?
Fred.
Yeah, so Bob, I like it. So Bob has 5 more than 3 times as many as Fred. So I've got to know Fred first. So if I call Fred F again, what will Bob's apples number be?
3F plus 5.
Good. 5 more than 3 times Fred. Now, I didn't even tell you how many apples they got together, or whatever, right? I didn't tell you any of that shit, but I was able to set these up. This part doesn't give a shit what the total number is or anything. That just captures the relationship. Let me make sure you understand that's a 5. That just captures the relationship between the parts of the problem. Now I could come up with something like this. You ready? Let me give you a little bit different. So now what if I said, oh yeah, I forgot, shit. Here's the rest of the problem. The difference in apples between them is, you got to make it work, Jeff. All right. Give me a minute. It's taking you too long. Is 9. How many does each one have? Let me show off my awesome grammar skills. So the difference in the number of apples between them is 9. So how would I set up that equation?
Would you subtract Fred's from Bob's? So 3F plus 5 minus F?
3F plus 5 minus F, that's the difference in their number of apples. And then I tell you it is.
Oh, equals 9.
I like it. So the problem we just did was like the income together, that's why we added. This problem says the difference in apples, so that's why I subtract these two. And then I can solve that equation. But see, I didn't need to tell you this part for you to do this part. This part doesn't give a shit. This part's like, here's what that is. Here's what the apples are. Once you know Fred, you know Bob. It could be anything. And then I go, okay, I want specifically the time when they have a difference of 9 apples between them. Oh, now I can solve for that specific instance. So then I would get 2F. I can subtract 5 from both sides. So get Fred has 2 apples. So then Bob would have 3 times 2 is 6 plus 5 is 11 apples. And to check it, 11 minus 2 is 9. Sweet. All right.
How I could know, like, I have to subtract the F, like, what's the, when you say the difference, that means you're subtracting?
Yes. What's the difference between 10 and 6? How different are they? What's the difference between 10 and 6?
4.
4. You subtracted them. So difference does mean subtraction.
Mm-hmm.
Like, just like if I said sum them up, or this, and that would mean addition, right? Okay. If I would have said Bob has, well, I mean, this times obviously means multiply, right? All right, so difference is a huge word that means subtraction. If I said together they have 9 apples, I would have added, right? Okay. So this is one part. It doesn't need this part to exist. It can exist. And then I could say, okay, I want them to have a difference of 9. So what if I said, has everybody got this problem? You guys got that written down? I could put a different number there. And the only thing that would change is that number, and then I could solve it. Right? So I'm not going to do that. I think it's too much. So I want, the big takeaway is this step is incredibly important. The people that make mistakes are the people that skip this step. So this is one step by itself. Then they tell me what these two do together. Maybe it's sides of a triangle and they tell me the perimeter. Maybe it's people and they tell me how much together or how much difference. That tells me how these two things come together to make something. That's where the equation is going to come from. Okay, maybe. All right. So what I want to do now, real quick, is to look at a couple actual problems in the homework so you know what to expect. Let's see, there it is, okay. Oh, shoot, that's not what I want. There you are, okay. Blah, 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 blah. Let's see. All right. Some of the homework, well, it's going to be an adventure, but just to show you, look at number 5, for example. Just read through it and see if it sounds familiar.
For 3-5 or 3-4?
3-5.
Oh.
Yeah, let me think. What was 3-4? Yeah, 3-4 was the inequality stuff. Sorry, I went. So we already did that. So look at number 5 on 3-5. Can somebody tell me, can you identify the piece of information they give us that's not important? Do you see what piece of information they give that I don't need for this problem? Can you guys see
The
that?
height of the wall.
Yeah, I don't. Yeah. So they just gave me this information right here, the height of the wall. They just gave it to me as like, oh yeah, by the way, it's a 3. If it was a 7-foot high wall, I don't care. It's not going to affect my problem because my problem is not about that. It's about perimeter. So take a minute and try to set this problem up. Draw the picture, identify the players, figure out who's just going to be a letter. Oh, yeah. Yeah. Okay. I'm going to kind of catch up to you guys. We've done a few of these, so already I'm pretty sure you guys all know the players are the length and the width. Which one of those did you just give a single letter to?
The width.
Yeah, because the length is to be twice the width. So I got to know what the hell that is first. So let me call it W, because I have no idea what the hell it is. And then the length is going to be what?
2W.
2W.
Just twice whatever this guy is. So I can use whatever letter I want to there, and this will be twice that. The letter doesn't really matter. W makes sense because that's W for the width. It makes sense. Just like we used F for Fred. So you can use the letters that make sense. You don't always have to use X. So let me put that on my picture because I know otherwise I'm going to make a silly mistake. So now I know this is going to be the perimeter. So what's the equation that I can set up then?
W plus W, 2W plus W.
Yeah, so I get W plus 2W plus W plus 2W. I can find all 4 sides in there. And that's going to equal
309.
309.
Kick ass. And now should come the easy step, or the easier step. 3W, 6W. It's not going to go in evenly, but too bad for us. It's not going to be that bad.
Fifty-one.
51.5.
51.5 what?
feet.
Now, to be honest, in this problem, they only care about how wide it is. So that's why I could stop right here. But if I wanted to figure out what the length was, I would just double 51.5. And I would get 103. But in this problem, they specifically just wanted to know the width. You guys see that? So I could just stop here because that's all the problem wants to know. All right. And then I like how number 6 kind of changes this a little bit. So I'm going to let you guys do number 6 on your own. I like it. So some of the problems in the homework are going to follow pretty much exactly what we've done. There are a few that'll be a little more interesting. So you have to get in there and try them out. Don't just give up, and don't ever just assume that a problem they give you has to fall into the format of a problem we've done. You just work with what they give you. And I know students always want to know, well, what kind of problem is this so I can just put it in the format and get done with it? Well, that's too damn bad. Don't all work like that. A few of them will, and a few of them won't. Okay. Let me clear this away. You guys all got that? So there's a gimme. There's one of your homework problems done. You're welcome. Still see people copying. I'm going to clear this away. Here we go. Uh-oh. It's going away. Bye, problem. Okay. 7 is going to be really interesting. I really want you guys to do that, number 7. See what you think. Number 9 is funky. Look at number 9 real quick. So you got to read the landscaping company, right? Read that through and then look at number 9. So you got to realize that this book very often asks a more basic question in the middle of other types of problems. Number 9 is not a word problem. Is there anything I don't know in number 9 that anything I don't know the value of to do number 9? I mean, I know the premium mix is $1.25 a pound. And I know the standard is 95 cents a pound, and I got 20 of each. So if I got 20 pounds of premium mix, how much money is that? How much money does that represent? Ah, crap. If I could just
20
write.
times 1 point or $1.25.
Yeah. All right. So the big problem with this problem is people think it's an actual word problem, but no, you know everything. You got 20 pounds, you know that. You know how much the premium is worth is $1.25 a pound. So then you would just do 20 times 125. And you're going to add to that 20 pounds of the standard. And so you do the same thing. So then you can figure out what the total price would be. Okay, so I just want to point out the fact that some problems are easy makes it hard because you assume them to be hard and you try to make them work some weird ass way. Number 9 is not a word problem. Number 9, you know everything. So you don't have any unknowns. There's no need for variables. But I don't blame you if you hit number 9, you're going to try to make variables because that's what you think the whole thing is about. But the book is pretty good about inserting questions just to make sure you're not too deep into a process, like you're trying to make everything fit that process. Just read the problem and do what it wants. Number 9, no variables. I know everything. That feels good. Okay. Number 10, same idea. I'm going to let you guys work on that one too by yourselves. Let me clear all this away. All right, so you got to get into 3.5 and try that stuff out so that you can come back to me with some questions. Just to look ahead, 3.6 is going to be interesting. You see how it's going to have, remember, how do you solve these kind of problems? This problem here, how would you solve this problem? What method can you use?
Multiply, like the opposite.
Cross.
Yeah, cross multiply. I love it, right? And the same thing would happen with this. What do you have to be careful about with part B? How does cross multiplication work? So I would do, oh, Jeff, that's not going to work, dude. There we go. I would do like 20 times 4 is 80. And what's going to go on the other side?
9 and then parentheses x plus 2.
Kick ass. So you just got to be careful. It's going to be 9 times this whole top. And now that becomes a relatively straightforward equation. You could just distribute the 9. You can solve that pretty simple, right? So once you cross multiply, you've got no fractions left. Kick ass. So the next section is going to deal with something called direct and inverse variation. Oh, that sounds painful. So somehow it's going to involve some of these ratio problems, these kind of things. Okay. All right. Personally, I think that's enough for today. I don't know if you guys agree. It almost doesn't matter because I'm in control. Nah. So let me know if you need to hang out. Let me know if you got any questions. And the quiz is open now. So you can actually, if you wanted to start right now, you could go start it right now. It works the same way as last time. Does anyone need to hang out? Anybody got questions?
Yeah, I have a question concerning the homework 3.4.
Okay.
Page 339, number 6.
All right, let me see. Come on, little dude. What's going on? There we go. It's a bad technology day for me. So question 5, you've got an inequality written, right?
Okay, so it just looks like my book is, okay, my book says something else.
Oh, really? What's your book say?
It looks like a typo.
Oh, shit.
Yeah.
All right.
Okay, that makes more sense.
Good.
All right.
Yeah, it depends sometimes on I don't think you did this, but there's sometimes something called an international edition of books, and that's normally cheaper, but they often have more mistakes and different problems sometimes. So that kind of sucks. So
Yeah.
I don't think that happened here, but yeah, sometimes the books are different editions based on where you buy them from.
Yeah, it makes sense. Okay, cool. Thank you.
You're welcome. How's everybody else? Anybody else questions? Uh-oh, let's see, I got a chat. Oh yeah, you too. All right. Seeing no questions, I'm gonna head out. Peace, everybody.